Some time ago, Michael Penn did this video where he had this figure over here and he wanted to find the shaded area right here. And he solved it in a certain way. I'll link that original video in the description. But I'm just going to solve it in a different way. So where do we begin with this? Well, we see that there are a bunch of lines. There are like these two triangles over here, AEB and DCB. And maybe we can shift this to the coordinate plane. Maybe that'll be easier. So if we shifted this to the coordinate plane with point B being at the origin, point B would be 0, 0, point C would be 12, 0, point A would be 0, 8, and so on and so forth. Now, all of these points seem to be pretty obvious except for this F right here. We don't know this point F yet. So if we solve for this point F, maybe finding this shaded area will be a lot easier. So let's try to find this point F. And the way we can do that is, we notice that point F is the intersection between line segment AE and DC. So if we can find this intersection point, then we basically found F. So we can treat line segments DC and AE as lines in the coordinate plane. So we have to give an equation for these two quote-unquote lines. Starting with line AE, or line segment AE, depending on what you want to call it, we see that the y-intercept is at 8. So this point is 0, 8. And then to get from A to E, you go down 8 and to the right 8. So down 8 to the right 8, that's a slope of -1. Minus 8 divided by 8 is -1. So we can say that AE, the line, has an equation of y equals -x plus 8. And what about line segment DC? Well, the y-intercept here is 0, 6. And then to get to point C, you go down 6 and to the right 12. Minus 6 to the right 12, minus 6 divided by 12, or -1/2. So therefore, line segment DC has an equation of y equals -1/2 x. And then again, we said the y-intercept was plus 6. So now we have our two makeshift equations for these two line segments. Saying them equal to each other will give us minus x plus 8 equals -1/2 x plus 6. Subtract 6 to get 2 on this side, add x to get 1/2 x on this side, you get x equals 4. And so if x equals 4, now we just have to find y. Plugging 4 back into one of these equations, let's just plug it into this equation. We have -4 plus 8, and that's y equals 4. So therefore, the point right here at point F is 4, 4. Now what good does that do? Well, now we can see that to find the shaded area, we just have to find triangle DBC minus triangle FEC. And we couldn't do that before without the coordinate value of F, but now we do know the coordinate value of F. So triangle DBC is just 1/2 times the base, which is 12, times the height, which is 6. So 1/2 times 12 times 6. But then we want to subtract FEC. Well, the base is 4, and the height now is 4, which is just the y-coordinate of point F. So we subtract 1/2 of 4 times 4. Now we just have to solve this. We get 36 minus 8, or 28, as the shaded area. Okay, great. That's a good place to stop.